Have you ever wondered how an app, a website, can serve millions of people all at once without just crashing and burning? Well, today we're diving into the architect's playbook. We're going to look at how to build systems that don't just survive under pressure, they actually thrive on it. Let's get into it.
So it really all starts with this question. Because, let's be real, whether it's a food delivery app on a Friday night or a streaming service dropping a season finale, that moment of peak demand, that is also the moment it's most likely to fall over. Figuring out why things break is always the very first step to building them so they don't.
And that brings us right to the core challenge, something every single developer and architect is dealing with, the modern systems dilemma. It is a constant juggling act between things that, honestly, don't always want to play nicely together.
What's so interesting here is how all these pressures pull in totally opposite directions, right? You've got to scale to millions of users, but at the same time, you have to keep the system simple enough for developers to actually use. You need different services to evolve on their own schedule, but the whole thing has to stay super reliable and secure. It's exactly this tension that forces us to get a lot smarter about our architecture.
Okay, so how do we start to unravel this knot? Well, our first and maybe most powerful tool is the API gateway. Just think of it as the single, organized, well-managed front door to your entire system.
This diagram just nails the concept perfectly. Instead of having clients trying to talk to dozens of different back-end services directly, which, believe me, is just pure chaos, every single request comes through the gateway. The gateway then acts like this expert traffic cop, figuring out exactly where each request needs to go. This one change brings so much order to the whole system.
And the gateway does so much more than just direct traffic. It handles all those tedious but absolutely critical jobs that every service would otherwise have to do itself. We call these cross-cutting concerns because they literally cut across the entire system. Things like checking who you are, making sure you don't send a million requests a second, and just making sure your request even makes sense. By putting all that in one place, our back-end services get to stay lean, clean, and focused only on what they're supposed to do.
So having a gateway is a fantastic start, but it's what happens at the gateway that truly matters. This brings us to the rules for designing APIs that are clear, predictable, and, most importantly, resilient.
These 5 steps, right here, are the bedrock of any great API. You start by defining your things, like users or products, in a really clear way. Then, you pick the right style for the job. Use standard methods so everyone knows what to expect. You plan for the future with versioning, and you figure out your error handling from day one. Get these right, and trust me, developers will love you for it.
And that second step, choosing an API style, is absolutely crucial. There is no single best answer here. REST, which works a lot like a normal website, is fantastic for simple public-facing APIs. But for super high-speed internal chatter between your own services, something like gRPC is way faster, way more efficient, and if your mobile app needs to grab very specific bits of data all in one go, well, GraphQL is probably your winner. It's all about picking the right tool for the job.
Okay, so we've organized our front door with a gateway. We've designed some really clean APIs, but to truly unlock massive scale and reliability, we need to adopt a whole new mindset. And that is the power of do it later. This is where asynchronous communication comes in.
So what on earth is an asynchronous API? It's actually pretty simple. Instead of making you wait on the line while it does all the work, the API just takes your request, immediately says, yep, got it, I'm on it, and then basically hangs up. The actual heavy lifting happens in the background. This one little shift changes everything when it comes to handling heavy workloads.
The best way to think about it is like ordering coffee. The synchronous way is you waiting at the counter, completely blocked. You can't do anything else until your coffee is made. The asynchronous way, that's when you place your order and they hand you one of those little vibrating buzzers. You are immediately free to go sit down, check your phone, whatever, until the buzzer goes off. I mean, which experience is better?
The simplest async pattern is what we call fire and forget. It's kind of like dropping a letter in a mailbox. You send your request, the API says, yep, we got it, and you just walk away, trusting it's on its way. You don't need a detailed response back, you just need to know your message was accepted. This is absolutely perfect for things like logging events or sending out non-critical notifications. Next up, we have the don't call us, we'll call you pattern. This is like leaving your phone number for a table at a really busy restaurant. You give the API your request and a callback address. Then you go about your business, and when the work is finally done, the system calls you back with the result. This is the foundation of webhooks, and you see it everywhere with third-party integrations. Then there's polling. This is the classic "are we there yet" pattern.
The API gives you a little job ID, and then it's your job to keep calling back and asking, hey, is it done yet? How about now? It's definitely simpler to set up than a full callback system, but it can be super inefficient if you ask too often, just like a kid in the back of a car. And finally, the most powerful pattern of them all, event-driven architecture. This is like a public radio broadcast. An API publishes an event, say, order created, to a central broker. That's our radio tower. From there, any number of other services can just tune in, listen for that specific broadcast, and react totally independently. Shipping, inventory, notifications, they don't need to know about each other, they just listen for the messages that matter to them. This is the secret to building truly resilient, incredibly scalable systems. So, we've got synchronous APIs, and we've got a few different flavors of asynchronous ones. How in the world do you choose the right path for your problem? Well, it all comes down to really understanding the trade-offs. So here's the bottom line. You're basically choosing between speed of development and resilience in production. Synchronous is easy. It's fast to get started with, but it's a house of cards under heavy load. One slow service can bring the whole system crashing down. Asynchronous, well, it takes a bit more thought up front, but you're building a system that can weather almost any storm. If you only take one single thing away from all of this, let it be this rule right here. If the user doesn't need an answer this very second, or if the operation absolutely must succeed, even if the system is slow, choose asynchronous. That's the secret to reliability at scale.
And hey, don't just take my word for it. These patterns are what power the biggest companies on the planet. Amazon processes your order asynchronously so the website never feels slow when you click buy. Google uses gRPC and massive event-driven systems to run its internal infrastructure. And pretty much every payment platform you've ever used relies on async APIs with callbacks to confirm your transaction. This stuff is battle-tested.
All right, we've gone through the theory, the patterns, the trade-offs. Now for the most important part, turning all this knowledge into action. So here's your challenge. Find one synchronous blocking API in a system that you know. And just ask yourself, does the user really need to sit there and wait for this? Then map it out. Whiteboard, piece of paper, whatever. What would that asynchronous flow look like? Would you use fire and forget? A callback? Maybe an event? And the most important part, justify why that pattern is the right choice. This little exercise is the fastest way to make these powerful concepts stick.
So I'll leave you with this final thought. We often think of waiting as a problem, something to be eliminated. But in scalable architecture, teaching parts of your system how to wait, how to do things later, isn't a weakness, it's your greatest strength. So which part of your system needs to learn that lesson?